Recall that in class we talked about 5 different types of chemical reactions. And the first type that we're going to look at in a little more detail is the synthesis reaction. So first, if we were looking at a synthesis reaction, how would you tell if it was synthesis? Synthesis reactions take the form of A plus B gives you AB. And one way we can look at this is that we can say we are taking an element plus an element and we put those together to get a compound. Remember that synthesis means to put together. Or to build. A chemical case that you might have heard the word synthesis before is photosynthesis. That is, the building of sugar molecules using light. A simple example of a synthesis reaction could be something such as lithium plus chlorine, and that will produce lithium chloride. Now I should probably balance this. And as you can see, I have an element lithium plus an element chlorine giving me a compound. Also note that chlorine is a diatomic element. So even though we are saying there's a 2 here, it's still considered to be an element. Another example could be hydrogen plus oxygen combines to make water. We are taking an element plus an element and making a compound. We can also predict the products of a synthesis reaction. And these are pretty straightforward. The only type I would ask you is for an ionic compound. So if I tell you we are reacting calcium with phosphorus, well, you know we have a metal and a nonmetal, and we combine that, we get an ionic compound. Calcium has a +2 charge as an ion. Phosphorus has a -3 charge. We can write out their multiples. See that their least common multiple is 6, meaning that the product is going to be Ca3P2, and we can balance that with 3 calciums and 2 phosphorus atoms. So synthesis reactions, element plus an element gives you a compound, and we can predict if we have an ionic compound what we're going to get. The second type of reaction that we're going to talk about is the decomposition reaction. What does decomposition mean? Well, in chemistry, it means the exact same thing as when we think of decomposition in any other sense. Decomposition means to break down or separate. The way you can identify a decomposition reaction is that you will have a compound, such as AB, and it's going to break apart into 2 components, A plus B. So we have one thing breaking into 2 things, and often we are talking about a compound breaking into the elements that make it up. It could break into two smaller compounds, it's possible, but in general we think of decomposition as one molecule breaking into its elements. Let's look at a few examples. The first one is, we'll do water. Breaks down into hydrogen plus oxygen. This is decomposition because we're taking this compound and breaking it into the products. And you'll notice that decomposition is the exact opposite of synthesis. So if you run a synthesis reaction in reverse, you get decomposition, because in the last slide about synthesis, we went these as our reactants and water was our product, but now we just switch that around. Another example we could do is KClO4 breaks down into KCl plus oxygen gas. So this is a case where this isn't an element, but we still have one compound breaking into two separate things. Or we could have sodium chloride break down into sodium plus chlorine gas. And to balance this, so we have one compound breaking into its elements, and that's all there is to decomposition.